And I will hit my timer so we can stay on time. You guys will appreciate that. All right, hey everybody, good afternoon. I'm Brendan Harris. Thanks for the opportunity. I appreciate the Dell crowd making this look more popular than it actually is. Way to go, guys. I work for Dell Federal Strategic Programs. I'm a retired Air Force Senior Intelligence Officer, and my job is to bring technology in a way that's accessible to warfighters, to those warfighters, and bring warfighter requirements back to Dell in a way that technologists will understand. So today, I have a couple of things I want to accomplish. First, I'm going to set some context for understanding the case study, which is really the meat of the presentation. What is this thing that we call CHEETAS that could be useful for a variety of different use cases? And then maybe at the end, if we have time, we can talk about those use cases, okay? That's my three purposes. So we live today in an environment that is dynamic, highly dynamic threat environment, arguably the most dangerous, most volatile threat environment, at least in several decades. I don't need to tell you that. That means it's important we get right what we all do collectively for national defense. The good news is that we have quite an opportunity, and we have some real positives that are on our side that our opponents do not. Some of those are listed. You might think, you're missing a few, but okay, let's talk about it afterwards and I'll add it to my presentation. No sweat. The one I want to highlight there is the tech advantage. And that's because we're in the tech world. We're in the tech industry, right? And we're going to use that technology for the benefit of national security, but we may not have the model to do that just right. The old school model for bringing technology and developing that technology was through a lead system integrator or a federal system integrator, an LSI or an FSI, that does a great job, for example, putting together a tank. They bring components from different companies, they bring parts from around the world, they build it into an M1 Abrams, and they turn it into something that does well on the battlefield. I almost use more colorful terminology. You also might think about a technical manufacturer, technology manufacturer, and Dell is well known in that way. Like, you all probably recognize us for our laptops and our PCs and our servers. We hope storage and networking, etc. And what I want to convince you, and part of my effort today, is that now I would like for you all to start thinking about something called a technology aggregator or a technology integrator. So when you have a data-related question, you actually turn to the technology aggregator and you go, hey, how would that organization, how would a technology-focused organization answer this data-related problem? Not necessarily turn to a LSI or an FSI, because they're going to turn to the tech integrator, but you could do that just for starters. And why is that? Well, I talked about the threat environment. It's also because we are in the data era. My presentation today is going to be focused on CHEETAS, which is not entirely focused on the F-35, but this case study largely focuses there. And then, like I said, at the end, we're going to apply that. So if you think about the data that is, coursing through aircraft, you can see that there are 3 orders of magnitude difference between the aircraft that I grew up in that world, the F-15C, that world is where I grew up, and now we're 2 generations beyond that with the F-35 and 3 orders of magnitude of data difference. That's a hell of a lot of data. And when the Air Force and the Navy and the Marine Corps and the joint partners were testing out this aircraft more than a decade ago, they were having a huge problem having access to the data. Okay, so this is just one example of data problems, and you can see, if you look over on the far right, that it took a really long time post-mission, 7 hours post-mission to get access to data, but that's okay because it cost you a ton of money, and that was okay because you didn't even have access, if you were the government, to all of the data. The lead system integrator had access to that data, but not the US government or other government entities that had paid for it. And so that government organization turned to, in this case, Dell, turned to a technology aggregator and started asking a series of questions in 2012 that were here, okay? And earlier on the right-hand side, I showed you a data lifecycle. Think about a technology integrator as being able to answer every part of that, okay? And so these are the kinds of questions they asked us, and you'll note that it goes around the entire data lifecycle. Hey, how do we process data better? How do we ingest it better? How do we manage it, store it? How do we make sure that it can be fused easily with other sources of information, whether they're live or they're virtual, constructive, whether it's a repository that's been sitting dormant for a long time? How do we make sure that it's discoverable by people who need access to it and can use it without necessarily needing to transport that data everywhere around the world, because we're not always going to have that ability, right? We may be in a DDoS environment, the data itself may be too much to handle, it may be cost prohibitive. How do we get to more powerful analytics to help us get to some sort of an insight? So the data in and of itself might mean a lot, but if we can't get any insight from it, like we can't analyze it, it means nothing. And then the last part on here is, how do we do so in a, well, cost affordable, but mostly open and non-proprietary manner so that the government isn't locked out of the data that it presumably bought when it bought that platform? They asked, how would Dell approach this problem and solve that? So Dell came up with this thing called CHEETAS, and somebody got a master's degree in acronyms from this, okay? CHEETAS is an acronym that stands for Cloud Hybrid Edge to Enterprise Test Analysis Suite. Whew. Yeah, and like I said, this case study is all about CHEETAS. Yeah, so what is it? CHEETAS is a framework. It is a baseline. If you imagine CHEETAS being that either gray or green base that's associated with Lego toys. Anybody have kids or play with Legos when they were young? Okay. CHEETAS is a base upon which to build. It's a framework, all right? It is an OSD, Test Resource Management Center. So this is an OSD, 3-star civilian-led organization. It is a government off-the-shelf capability. If you have a CAC, you could download this free of charge and play around with it right now. The beauty of it, of that part anyway, is the Test Resource Management has a very large budget, and they are willing and able to pay for APIs for your particular test cases, your use cases, which is really nice. And here's me offering their money, so maybe don't quote me on that, okay? And you're going, all right, so tell me what this is and how it answers the mail. If you start in the top left, this is the design that Dell engineers came up with to answer all of those questions that I asked before. All right, it starts with a QRIP, a quick reaction instrumentation package that fits up in the weapons bay of an F-35. It has access via the fiber channel to every bit of data that's going through an F-35, and that's important because an F-35 is not just a strike platform, it is a penetrating ISR platform. So that mission data is now available via the QRIP, which right now cannot record every single bit of data across an entire mission. There's just too much, so it's pilot selectable. But each QRIP-equipped aircraft can store 1.2 terabytes of data, which is a lot, and that's going to increase with newer generations of the QRIP. When the plane lands, by the way, this is not processed and transmitted in real time. That is a decision from the F-35 Joint Program Office. The F-35 is a SAP platform, and they don't want that sent out to the rest of the world. So the aircraft actually has to land, the recorders are pulled off, the memory is pulled off, it's put into a machine. That's what you see in the middle, that knowledge management stack where it says KM system. On the home station, 8 minutes after that, the pilots are ready to have a debrief. So all the data, the external data, whether it's weather or adversary aircraft or surface-to-air missile shots or just other blue forces, all of that is integrated within 8 minutes, which is a lot of data. And it doesn't matter how many F-35s, if it's a 4-ship or an 8-ship or whatever, it doesn't matter, it's still 8 minutes. 20 minutes after that, we have access to the full engineering units and can start the big data analytics. That's important to me as an ex-Intel guy, because now I can start doing things like thinking about electronic warfare reprogramming. I can start the targeting cycle all over again. What did we hit? What did we miss? What's new out there? I can start planning our next missions based on that. And all of that leads to visualizations and products at the ready. That product-based information and the data, all the big data, is also what's called federated. So if you're on what the world calls the Bolt network, so that's the F-35 is the Lightning II, so it's a specific F-35 network that has capability up to SAP. If you're on that and you have access, no matter where in the world you are, you have access to that data. So combat air forces, F-35s, forward deployed to Spangdahlem Air Base in Germany from Hill Air Force Base in Utah when Russia invaded Ukraine 2.5 years ago. When those aircraft landed, after the data was processed, that data and the ability to analyze what was happening in those jets, whether it was avionics or weapons or, I mean, they didn't drop or shoot anything, but it could have been. Any of the electronic warfare, any of the ISR mission data was available from Spangdahlem without moving the data. It was available to Hill or Vermont, where they also fly F-35s, or Nellis Air Force Base, or Point Mugu, or Patuxent River, or any of the other joint F-35 bases, just as an example. So that's part of it. Now, what you might be asking is, what about at the edge? Because I highlighted that that KM stack in the middle there was specifically for home station. Well, the Rapids smaller stack on the right-hand side, that is for deployment. So it has similar capabilities. It obviously doesn't have as much memory, and it doesn't have as much storage. So it's a little bit slower in terms of its processing, not significantly. And it can't store, however many missions worth like the larger stack can. But otherwise, it has the full effects. So in sum, what can Cheetahs do? It can do almost everything across that data lifecycle that you would need it to do. Certainly everything that the Test Resource Management Center has asked it to do, from ingesting and warehousing and analyzing and creating those products, managing the data and tagging the data, and it is completely extensible via APIs. It runs on a series of containerized microservices, to be clear how this is orchestrated. So it's modern code that was written for these purposes. And so how has that changed things? You remember before when I said it was expensive, it took a long time, and you didn't get all your data if you were the US government? Well, now it takes mere minutes. You have, if you're the US government, access to all of your data, and it's a fraction of the cost. So the original recorder thing, which was called a Dart pod up in the top left, that's a $2.5 million, 8-foot-long container that doesn't store all the data that you would need. This is old school, and it takes up an entire weapons bay of an F-35. That Q-RIP is the size of a cigar box. It fits up in the weapons bay, and it doesn't preclude any weapons use. And it's about $200,000 per install in comparison. So dramatically different outcomes as a result of turning to a technology company to answer a technology need. And so, how do we use that for other use cases? It is super clear to the Air Force. They're applying this same model to the F-22 and the B-21, the B-52, the B-1. I mean, you could go down the list in prioritized order of which aircraft they're going to apply it to. The Navy is going to apply it to their aircraft, F-18, even the MQ-25 program, just as an example. But you're sitting there going, okay, I'm not in the aircraft business. I'm in tactical radios. I'm still going to work on that one with you. I'm not really sure, but... So what else could we use either Cheetahs or this idea of a technology integrator for? Well, I mentioned earlier that this is helping with targeting cycles, right? When the Air Force wanted to pull those forward deployed F-35s out of Spangdahlem Air Base, the then USAFE commander, a guy named General Cobra Harigian, said, you can swap the pilots, but you ain't getting your aircraft back. These aircraft are providing us a treasure trove of intelligence information that is helping us with our just-in-case targeting cycles. We're not letting it go, okay? Because of the speed to mission need. You could also use it for rapid reprogramming at the edge. This is something specifically within the Air Force that we've talked to the 350th Spectrum Warfare Wing, but it applies across the DoD services. If you have that information, you have the ability to parse out very, very quickly what's brand new with super high fidelity. Now you have an environment that's ripe for reprogramming, and you have the ability to do that all the way to the edge if your policy and bureaucracy, the culture, would align with that. Probably more useful, even more useful, would be predictive maintenance and the ability to know what's going on in those aircraft or your equipment writ large, okay? So we've talked to, for example, the 160th SOAR about that in particular, just as an example, because you have such insights. One of our data scientists he wrote a machine language crawler to look at Pax River F-35 data, their engine data after a series of flights. As a result of what he found, just using a relatively simple machine language algorithm, he found a number of cases where aircraft in flight were shutting down the engines for 300 milliseconds at a time, uncommanded by the pilot. So, like, if you're a pilot in those circumstances and your jet is telling the engine to shut off and you're not telling it to do that, you probably want to know why. So they did root cause analysis, and turns out there was a faulty sensor that was indicating weight on wheels. They were able to replace that sensor for a couple $100, saving, a pilot, an engine, an aircraft in each one of those cases. It's that kind of insight that CHEETAS helps enable. Some other potential use cases. You could speed up your modeling and training with, speed up your training with modeling and simulation. I talked about the ability to fuse a variety of live, virtual, and constructive sources of data. CHEETAS enables that environment. You would need to layer on top of that, but CHEETAS enables that environment. It is also built, I've already talked about ML, a specific ML example. The exact CHEETAS program has not yet dived into the AI realm, but you can see it's an environment that's ripe for the use of artificial intelligence to improve and strengthen the analytics. And now, how do you apply that? The cost for you is essentially free. Like I said, you could download it right now with the CAC. So now, how do you apply that, and how do you layer on your own AI and ML algorithms? And then it is built to be consistent with both the zero trust architecture and MLS CDS environments. So that microservices structure is consistent, and in future iterations, in fact, the next iteration of CHEETAS will support a multi-tenancy environment as well. So that concludes my briefing. I think I have all of 1 minute and 35 seconds to go in terms of my time. So I'll open the floor for questions or comments. Stunned. What did he say in the middle? All right. Well, I thank you for the time and attention. I wish you good luck in getting your continuing education credit. I don't know if it was worth it, but yeah, thanks so much.